This is section 8-8, and so this one we're going to talk about chemical sedimentary rocks. There are 7 major types of chemical sedimentary rocks, and they are basically classified based on their composition. So they're all crystalline because, remember, they're chemically precipitated, just whether they're crystalline or microcrystalline. It's just that they're small crystals or bigger crystals, and sometimes you can't even see the crystals in the bigger crystals. So the first one is chert. Chert is microcrystalline or crystalline, and it's made out of silica. It has a hardness of 7. So the easiest way to tell if it's chert, if you can't see, you're not going to be able to see any grains. So it's only made out of quartz, and it's going to have a hardness of 7, so it will scratch the streak plate instead of leaving a streak. Dolostone is made out of dolomite, which is calcium, magnesium, carbonate. So it has magnesium in it. It still fizzes in acid, but it only fizzes in acid when in powdered form. So that's the way to tell the difference between dolostone and limestone. Limestone can be microcrystalline to crystalline. It's made out of calcite, so it fizzes in acid. Micrite. Micrite is a microcrystalline carbonate mud. It's generally grayish. It will still fizz in acid because it's still carbonate. But if you look at it with a hand lens, you'll see grains and cement. Rock gypsum is made out of gypsum, so it will have the same properties as gypsum. Rock gypsum usually is white and a little bit more powdery. You're not going to get nice little crystals like you would in crystal form of gypsum. Rock salt is halite, so it tastes like salt. Travertine is a type of limestone, so it does fizz in acid. So it does fizz in acid, but it has this pattern to it. Travertine is a very common tile for flooring now. Basically, when you get calcite mixing together, or water that has a whole bunch of calcium carbonate mixing together, it will precipitate out travertine. Okay, so these are just some examples of what we just looked at. This is rock salt. This is rock gypsum. So this is going to be very soft, just like the mineral gypsum. C is just limestone. Limestone can really be any color. Generally you see it as tan, but it really can be any color. You can kind of see the crystals in the limestone. This one is travertine. You can see it has this pattern to it. This is your micrite, fine grain limestone. It's your dolostone. Dolostone can be tan, just like limestone, but the only way you know it's dolostone is that it won't, if you put acid on it, it won't fizz unless it's in powdered form. And this last one is chert. Chert can be in a wide variety of colors. If you've ever heard of jasper or flint, those are just different colors of chert. Okay. We're also going to talk about the biogenic sedimentary rocks. So there are 4 main types of biogenic sedimentary rocks, and they're classified on basically their compositions the same way as the chemical sedimentary rocks. So chalk is going to be clay or mud. It's going to be very chalky, but it's going to be made out of coccolithophorids. If you don't remember what a coccolith is, go back to chapter 21. I talked about them in the lecture. The textbook talks about them. They're little microscopic organisms that float around in the ocean. They die and they accumulate and make chalk. So like chalk for chalkboards, you're writing with little dead skeletal organisms. The White Cliffs of Dover, it's chalk. It's made out of all these billions and billions of dead little microscopic organisms. So chalk writes, it's just chalk, what people used to use for chalkboards. Coal, it's concentrated carbon. It's made out of dead plant remains that have undergone extreme pressures. Your textbook has 2 pages on how coal has formed. It's not super complicated. It's all based on heat and pressure. So I recommend reading those 2 pages in your textbook. Coquina. Coquina is basically sand or gravel size, and it's all just shell fragments that have been compacted. They're actually not cemented. There's 2 places in the world that still mine coquina, and one is actually in Florida. If you ever get to go to St. Augustine, Florida, there's a fort that's made out of coquina. Coquina has this property that when it's hit by a cannonball, it actually just absorbs the force and doesn't fracture and break. So the Spanish made a fort out of coquina. But all it is just crushed shells that has been compacted together. If you've ever been to a beach on the northeastern coast of Florida, there's got a lot of shells on it that get crushed, and the weight and the burial pressures make them stick together. And then limestone, visible or microscopic skeletal fragments. You can have limestone made out of forearms, which you can't see, or it could be made out of fossil coral. So as long as there's just fossils that are part of it, it's now part of the biogenic limestone and not just the true chemical limestone. So D is coal, C is chalk. This is your fossiliferous limestone, which you would never be able to tell it's fossil. If I give you fossiliferous limestone, there'll be obviously fossils in it, and this last one is coquina.